inverse sine, inverse cosine, which we've already talked about this. We've already talked about the graphs. And that's a little bit about what I want to make sure you have today. So 6.4 is inverse trigonometric functions. And right triangles. And that's the important part. We're talking about right triangles today. And this is the first part I'm going to show you today. Would be a good thing to put on your card sheets, so you have them. You're going to want them as you're doing your homework, and you'll be pulling it out probably almost every homework assignment. So you're going to want this stuff. All right. So the first thing is the arc sine of x equals y. And you know what? Let's just change this. This is what it says in the book, x and y. Let's just use m and n. All right. So these are just positions that I'm talking about.
Do you have any more of those?
Yeah, they're right up here. If you guys need more, just come get them.
Wait, so is that something we should put on our formula sheet?
I would put it on there because you're going to, this whole thing, I'm going to put a few things right here that I want. I would put them on my formula sheet because of what is going to be over in this spot. All right. Basically what your inverse is saying is, how did I get this answer? What was the value of y that gave me this answer? That's what the inverse means. You're working the problems backwards. So if I said the sine of pi over 3, that's the y value at 60 degrees. The y value at 60 degrees is what? Radical 3 over 2, so the long leg in that right triangle of your unit circle. So if that was a struggle for you, that's okay. It just may take you a couple minutes longer than others. That's all right, but you got to be able to do that on the basics, 30, 60, 90 degree in the unit circle and then all the way around. That's why I gave you that unit circle yesterday, to kind of kick you back into understanding that and learning it. But the point is, the sine of 60 degrees, pi over 3, is radical 3 over 2. Inverse would be asking you the opposite. What is the arc sine of radical 3 over 2? You would say 60 degrees, or pi over 3. So it's just, the inverse is just the backwards of what we've been talking about. That's it. Okay? Working it backwards. That's why I said way back when, make sure you really have mastered the unit circle. It's not that you can't figure this stuff out. It's just if you've mastered it, it's going to make your homework go a lot easier. If you have to have your unit circle out doing your homework, then get your unit circle out and have it there so you can get used to it. But try to make yourself come up with the answer before you look at your chart to help you get back into it. If you have not mastered it yet, figure it out. All right, get back into it, and let's make sure we can do it. So this is just the opposite of what I just said. Oops. So that'd be the sine of n equals n. Notice that these two switched. And this is just the example. I could put pi over 3 in there. Maybe I'll do that. All right, so, but the point was when we did the graphs of these inverses, remember how ugly it was when we did the graphs? We learned a few things. We learned that the domain of the arc sine was -1 to positive 1. And that the range, and these are the important things that I'm putting up here for today, negative pi over 2 to pi over 2. Meaning, my values that I'm looking for are in the fourth quadrant and the first quadrant. Negative pi over 2 is down to 270 degrees. Fourth quadrant into the first quadrant. That's what that means. Alright, that's key for later on. Alright, so now let's talk about the arc cosine of m and n. So the arc cosine is the exact same thing. What value do I get when I ask for the opposite? So instead of saying the cosine of pi over 3, I would say the cosine of 1/2. The arc cosine of 1/2 would be pi over 3. So the cosine of pi over 3 is the short leg. That's the x value, which was 1/2. If I'm asking for the inverse, I wouldn't ask for the arc cosine of pi over 3. I say the arc cosine of 1/2 is pi over 3. Remember, it's just the opposite of what we started with. So the cosine of pi over 3 is 1/2. So that's my n and that's my m. So the arc cosine of my answer gives me what I started with. That's all the inverse is. Everybody following me? Working the problem backwards, that's it. Alright, so the domain of the arc cosine is -1 to 1, just like the sine. And then the range is 0 to pi. Here we're dealing with which quadrants? From 0 to pi. First and second. 0 to pi. Here's pi right here. So first and second quadrant. 0 to pi. Okay? And then on this one here, negative pi over 2. Pi over 2. Why is it negative pi over 2? Remember when we graphed it, the basic inverse sine function was moved to the left by pi over 2. So that's why we say it's negative pi over 2 to pi over 2. Because the graph, the visual part of it was shifted to the left, behind the y-axis. So, just giving you a heads up, we're not thinking of the fourth quadrant as 5 pi over 3.
That's right.